Okay, so here we are. This is a little video on solving differential equations. I think this is quite a cool little section and very advanced. So this is essentially, I see it as like integration, or like the integration version of implicit differentiation. Because if we can see here, sorry, don't know, that's dragging. Sorry, I'll see if I can fix that. We can see here that we've got things in different variables. And when we look at in implicit differentiation, that's where we've got like something x times by something y, and we don't want to rearrange it. We just differentiate it in that form. This is if we've got dy by dx equals a function of x multiplied by a function of y. We use this method to split the things up, get our y's on one side and our x's on the other side. That includes the dx and the dy. And then we can integrate both sides as usual. And we have an equation where we kind of integrate down both sides. And we put that stuff together. We'll see an example. It'll make a lot more sense. What we'll be looking at first is getting a general solution. What that really means is we just don't find what C is. So, like this, for this one, that if we just leave it as a plus C, that's a general solution. This is not a differential equation. Well, it is. It's just a very simple one, you know, just standard integration. But we can see that plus C there. So we could have loads of solutions. It's a general solution. So as long as it's 4x cubed minus x plus or take away any number, we're all good to go. So these three things could be perfect solutions. This is just where we put minus 1 in place of C. This is just where we put a 0. This is one where we put a 1. And we can see we can have a load of different solutions. We sometimes get asked to find a specific solution, and that's where they give us enough information to find out what plus C is. And that's sometimes referred as a boundary condition. So that's kind of like the basics of what we're trying to do here. Essentially just another integration tool to help us integrate something where we have something in terms of x and in terms of y in the same question. The method feels a bit funny at first, but you just got to practice it and you will get used to it. So hopefully my pen doesn't drag too much. We can see here that we've got something dy by dx equals to something with x, something with y. We want it to say something 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 dy, that something 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 will all be terms of y, equals to x dx. So that's our first aim. So we want it to say something in terms of y dy equals to something in terms of x dx. So let's start this question. 1 plus x squared dy by dx equals x tan y. So first thing I'll do is probably times by dx. So 1 plus x squared dy equals to x tan y dx. And then I'm going to divide by 1 plus x squared. So that gets me dy equals to x tan y over 1 plus x squared, all by dx. And then I'm going to divide by tan y, because I don't want the y's on that side. So 1 over tan y. I always write it so the dy and the dx are not involved in the fractions at all, because that's what we're used to seeing when we integrate. They're kind of just popped on the end. X over 1 plus x squared dx. Okay, if you're confident in doing that all in one go in your head, feel free. You don't have to spend 5 lines to do that rearrangement. I just wanted to show exactly what I was doing. Past this stage, when we've got something in terms of y dy, something in terms of x dx, that is exactly how an integral looks. So we're doing the same to both sides, so this is completely acceptable. Pop an integral sign on both sides. And that's what we're going to do now. We are going to integrate both sides, and we'll see how it works out. Let's integrate this. So in fact, we don't have an integral for 1 over tan y, but we do have an integral for cot y. Cot is a funny one. It is ln sine. I think that's one that's given in your formula book. And then this, we're going to do this via a reverse chain rule. Very popular one in here. Quite often you get lots of lns involved in this stuff. So look out for your reverse chain rules. If I do that one, it's going to be half ln 1 plus x squared. And in this, we don't want to forget our plus c. And remember, I've spoken before, instead of writing plus c, because all of these other things are in ln, I'm going to put plus ln k. That is just a number. Yeah, ln k is just a number, and that is in place of plus c. And the reason I'm putting plus ln k is that means I can use log laws to combine that ln k with all the other stuff. So it looks a bit neater and tidier, and then it gets easier to, when we go ahead and find a specific solution, it gets a lot easier. So let's just tidy up the log laws on that side before I get rid of the lns. So this is going to turn to ln. This is going to be the square root of 1 plus x squared, because that means I can put it to the power of a half, and a power of a half is a square root. And then when I add this on, it means I can times by k. So that all tidies up to look like that. And the reasons again for that is power of that I can bring to a power of a half, which is square root, and then I times by, if I'm adding lns, I can times by that. Okay, from this stage I can get rid of the lns, so I can just say sine y equals to k square root 1 plus x squared. And in fact, they haven't asked for this to be like y equals. Sometimes they will, but they haven't in this case. So I'm just going to leave it there. And that is done. So it's rearranging it and then integrating. General solution this time. So we're not going to find the value of k. We will just leave it like that. And that's all it is for that bit. So you may want to now just have a bit of a practice of question 1 in the exercise from 11.10, because they are based from these things. So it would be a good idea to just take 10-15 minutes now to see if you can do 1 or 2 of these and get your head around it. If not, come back, watch this example again, and if you've got it, we're going to do example number 2 now. Okay, second and last example. Make that touch bigger. So find a particular solution. So all that essentially means is find the value of plus c, which we're going to most likely write as plus ln k. So you'll find the value of k in this case. And here we've said given that x is 1 when y is 4, that's going to help us find what k is, because if we just scroll back to this example, we can see we could have substituted in y and x here, find a value of k. So that's all we're really doing, to be honest, that one final step. And it's sometimes referred to as a boundary condition. So I am first just going to write the question out. Okay, first of all I need to get it to say something dy equals something dx with the same letters either side. So if I divide by y minus 2, and at the same time I'm going to times by dx, so that gets me 1 over y minus 2 dy equals to minus 3, stuff on the bottom of the fraction, dx. Yep, so that's popped over there. Sorry, this has popped over there, and the y minus 2 has popped over to the other side. Again, I can pop an integral in front of both, doing the same to both sides, it's cool. I'm going to omit some of the working, but you would do partial fractions here. You know, just like we would do usually. We should do partial fractions there, and we'll end up with this equaling the following. Okay, and then this is still going to be like that. I'm not going to integrate it yet. I'll integrate them both at the same time just so it looks neat. What I want to do from there is integrate now. So this is going to get me ln y minus 2. This is going to get me ln x plus 2. Subtraction, sorry. That should be a subtraction. Get the rubber. Subtract. This is ln 2x plus 1. And then for my plus c, I'm going to write plus ln k. Because ln k is just a number. C is just a number. Makes no difference which one we use. Let's tidy up our logs. You've always got to tidy them up before you get rid. You want like one ln on one side, one ln on the other side. So this subtraction sign, that means we will divide. This plus sign, that means I will multiply. So how that's going to look is x plus 2 over 2x plus 1, and then that's all going to be multiplied by k, and I'll put that inside the ln brackets. I can get rid of my ln's now, so y minus 2 equals to x plus 2 over 2x plus 1 k. That's the general solution. So if we were asked for the general solution, actually my next line is going to be the general solution. Let's add this 2 to the other side. So y equals, because can we see here it says it wants it in the form y equals f of x. So 2 plus this. So that's my general solution. If that's all we were asked for, we would finish there. But we know when x equals 1, y equals 4. So let's substitute them in. 4 equals to 2 plus 3 over 3. K, which is just 1k. So 1k, take away the 2. 2 equals 2k. And then, final step is to just put the k back in. So y equals to 2 plus x plus 2 over 2x plus 1 times by 2. And it doesn't really say to simplify it, but let's just do a few steps of simplification. So you could probably leave it like that. Maybe you just want to times the top by 2 to not be super lazy. So we're going to have this 2x plus 4 over 2x plus 1. With this being a top-heavy fraction, we might want to, if we're going the extra mile, we might want to make it a non-top-heavy fraction. So I could write that as 2 plus 2x plus 1 over 2x plus 1, which will equal to 1. And then from that 2x plus 4, I've got an extra 3 left over, because 2x plus 1 plus 3 gets me 2x plus 4. So that is 2 plus 1 plus 3 over 2x plus 1, which is 3 plus 3 over 2x plus 1. So what I've done here, I'll put brackets around it, is just going the extra mile. It hasn't asked for it in that form particularly, so we don't need to. It may just help with some later steps, possibly, I'm not sure. But that is finding a specific solution. Okay? So it looks like we've done something pretty cool. That looks horrible. And we've come out with something pretty cool and nice. That is going to be like question 2 from the exercise from 11.10. So you may want to then take 10-15 minutes to practice that. If you get them right, good, you're ready for the lesson. If not, see if you have a look back at the example and give it another go. Okay, thank you.